So let's take a look at some of the networking examples. The first example that we're going to look at is we will have a button in an applet. When you click at the button in an applet, it will load another page. So it's going to act something like a link. So we just specify the URL, and that particular URL will get loaded onto the same page where the applet was loaded. So let's look at this particular example. So we have class ButyLink extends applet implements action listener. We have declared a button object. In the init method of the applet, we have defined the button, added the listener to the button. As we have implemented the action listener on the same class, that this reference is being passed, that's nothing but the listener object. Add the button to the container, that's nothing but an applet. Now when we click at this button, we are supposed to load another URL. So therefore in action performed for a button, we create a URL object. Creating a URL object, we have specified a page called home.html out here. To load the app page onto a applet, where the applet was loaded rather in the same browser window, what we need to do is invoke the showDocument method. ShowDocument is a method in the applet context interface. Applet context interface again resides in the applet package. Now a applet context is nothing but within which all the applets get loaded. So you can load any number of applets into your web browser. So all the applets loaded into a web browser, they all belong to a same applet context. So to get the object of type applet context, we invoke the method called getAppletContext. This returns applet context object, and upon this object we invoke the showDocument method, passing the URL object as parameter. Now by default, what happens when you click at a link on a HTML page? It loads the page onto the same window where the link was loaded, unless and until you specify a different target for it. Similarly, even out here for the showDocument, it's going to load on the same page where the applet was loaded. So if you want to load onto a different page or to a different target, then you must specify that target as a second parameter to the showDocument method. Now let us look at how to execute this particular program. So we have out here an applet tag defined in a HTML file for ButyLink. The applet size is 300 by 300. So now let's execute with this. So here we get an applet with the button. So when you click at the button, it loads the next page. That is nothing but the URL specified, which is our home.html page. What we have seen right now is we specified the URL and we loaded the specified URL. Now what if we want to specify the URL, read the contents of that particular URL, what the page it's going to return, and we want to put that into one of our components. So that's what we're going to look at next. We're going to have a text area in an applet. Into the text area, we're going to load the page which has been specified. In order to execute this, we have a class netTest which extends applet, implements runnable. Inside a thread, we read the contents of the specified URL and put it into a text area. So we declare the URL object, the thread object, define the text area. In the init method of an applet, we are defining a URL to a page, and in this case ButyLink.java itself. Add the text area to the container. In the start method of an applet, we are checking whether thread is null. If it is not, create a thread object by passing a runnable object to it. Start the thread. In the stop method, if the thread object is not null, stop the thread. So if the applet goes out of focus, you wouldn't want the thread to keep executing. The run method of a thread, we want to read the contents of the specified URL. So how do you read the contents of a particular URL? Remember, we need to call the method called openStream on the URL object, or what you need to do is call openConnection, and then from the URL connection object which openConnection returns, we can use the getInputStream. Using the InputStream object, we can read the contents, one and the same. So we are using the openStream method of the URL class, which returns an InputStream object. IS is nothing but an InputStream object. Since we want to read line by line of the file, we are also using data input stream. We're going to read line by line from the file. We keep every line that we read, we're going to put it into a string buffer, and then finally the entire content of the file is in the string buffer. We are going to put it into a text area. So therefore we have a string object declared and a string buffer object declared. Now once you have an input stream object, you pass that input stream object into a buffered input stream here to enhance the program execution, because if the file content is huge, the processing becomes slower. So to increase the performance, we have made use of buffered stream object as well. So we pass the input stream object into a buffered stream object. This particular buffered input stream object we are passing to a data input stream object. Remember, both of these streams cannot stand by themselves, as buffered stream just gives you a buffer, whereas data input stream gives you various methods to read with. So finally we need to know where we are going to read the contents from. That's the input stream object for the URL socket. So once we have a data input stream object, we are calling the readLine method of it to read line by line till we reach the end of the file. That's the null check. So every line that we read, we append it to a string buffer. And finally, once we are done reading the entire content, set the content to the text area by calling the setText method and passing the string buffer.toString as a value to it. Because the setText method takes a string object as a parameter, we need to convert the string buffer to a string object by calling toString method. Now let's take a look at an example. Let's take a look at how it runs. Going back to the HTML file, we'll change this beauty link to a net test. So if you were to run this particular program, you would see that the contents of beautylink.java will get displayed into the text area. Now let's move on to the next example with UDP, where we looked at a client sending a message to a server, and that message would get displayed at the server. So we have echo client, echo server as programs out here. The echo client program, it declares the datagram socket and packet objects, and then of course the byte array into which the data would be entered, the buffered input stream object which takes as parameter system.in, that's an input stream object. We're going to enter character by character from the keyboard, and that content has to be placed into a byte array and sent to the client. So system.out.println of enter message, we are displaying for the user, prompting the user to enter a message here. Bin.read, we're going to enter character by character. This entire content will get into a array. So bin.read message, that is nothing the byte array, starting element of the byte array, and how many characters we want to accept. So beyond this, it will not store into an array. So you enter the entire content, and once you're done, then that content will be passed on to a server program. So we have inet address.getLocalhost. Since I'm going to be running both the client and the server on the same machine, so we are calling for getLocalhost method. Otherwise you can call get by name of whatever the machine where the server is running. This getLocalhost will return an inet address object. We are creating a datagram socket object and a packet object. While creating a datagram packet object, this is for sending a message, so there are supposed to be 4 parameters passed through this, and that is the message MSG, that is the byte array, how much of the content you are sending across, the inet address object, and the port number at which the server would be listening. And here we are using port 7, which is an echo port, or you can use any other port which is beyond 1024. Sorry. Once you are done creating a datagram packet object, send the packet. So socket object dot send of packet. Close the socket object. Now to the server. Server again creates the socket and the packet objects, creates a byte array of 256, creates a datagram socket specifying at which port number it's going to be listening on, that's port 7, to which the client is sending the message. Datagram packet object is being created, specifying the byte array and the length, how much you want to receive. So using the socket object, you call for the receive method of the packet. Once you have received the content, remember the receive is a blocking call. Once you have received the content, then you can on the datagram packet call getData method, which returns a byte array. And as we said, this byte array you will not be able to read the contents of, so you need to convert it into a string. So this byte array is being passed to a string object, and that is being displayed at the console. Once you are done with that, close the socket object. Now let's see how to execute this. First run the server and then the client. So Java echo server. And Java echo client. So here the client says enter a message. So at this point you type in whatever the message you want to send to the server from the keyboard. So once you type in the content and press enter, the content gets passed to the server. At the server, the content is displayed. If you notice that there is so much of space out here, that's because the byte array is 256 and that's the content that you are displaying. What you could do is you could trim the content, the string object, before displaying the content to the console, so you don't get this empty spaces. This is your UDP example. Similarly, we'll now look at the TCP/IP or the socket programming. But in case of the socket programming, what we're going to do is we are going to have the client first send a message to the server. The server will pick up that message and then it will reply back to the client. So once the client has sent the message, it is listening for the server to send back some reply. Once the server sends back the reply, now the server would be listening for the client to come back, and the client writes back to the server again. Like this happens until EOT is typed from the client in this particular example. So this is like a chat between client and server. Now let's see how this works. We have a client program and a server program. In the client, we are creating a client object itself and calling the user-defined method called con. The client needs to create a socket object specifying the machine name and the port number at which the server is going to be listening on. Then we create a data input stream object for system.in. We're going to accept from the keyboard line by line at a time. So we need a data input stream for the standard input device. We're going to send a line at a time to the server. Similarly, the server needs to receive a line, and again it needs to enter a line at a time from the keyboard and send back to the client. So here, once that's done, we have a string object declared into which we're going to store the content to be sent to the server. Now you need both the socket output stream and the socket input stream, because both the client and the server is doing a send and receive. That is, it's going to read and write to the socket. So we are calling a socket objects get output stream, passing this get the output stream object to the print writer, and the second parameter to print writer is true here. Now why is it that we don't use a data output stream instead, which has been commented out here? The reason behind this is, if you use a data output stream, you have to flush explicitly, whereas with print writer object, if you pass the stream output stream object to it with the comma true as a second parameter, it's an auto flush. So we're going to be using a print writer object instead of the data output stream to write a string at a time to the socket. Now we need to also get the socket input stream, because we need to read whatever the server sends back to the client. So we pass the socket input stream by calling for sock.getInputStream to the data input stream, so we can read line at a time from the socket stream. Remember, the chat goes on till EOT is entered by the client, so we are in a while true loop, do while true loop. So first thing that the client does is enters from the keyboard a string. So we have a prompt enter string, dis.readline. Dis is representing your system.in, so you are entering from the keyboard. Whatever you enter from the keyboard is stored onto str, string variable, that you are writing to the socket output stream using out, which is a print writer object representing the socket input stream, output stream. Check whether the string is EOT, if so come out of the loop, otherwise we are calling a read line for the socket input stream, waiting for the server to write back. So this is again a blocking call. Till we get the message, we keep hanging on at this method. Once we receive a message, the read line comes out of its call and then displays the content what the server has sent, goes back, enters from the keyboard, writes to the server socket again, and again waits for the server to enter something back. So once it comes out of this loop by entering EOT, end of transaction in this case, we are closing the socket stream. This is the client program. Now moving on to the server. The server program has a main function within which we are creating server's object itself, server class object itself, and calls the serves method, which is a user defined method. Now this particular method creates a server socket object for 8001 port number, because that's the port at which the server is going to listen on. And this is the port number that the client has referred to when he handshakes with the server. We have declared a string object variable and calling for the accept method on the server socket. The accept method is a blocking call which basically is waiting for the client to connect to the server. So once there is a connection established by the client by creating a socket object in the client, that's when the accept comes out of its call. So this is where the handshake occurs. Now once you have a socket object, the server needs to get the socket's input stream and the output stream object, since it's going to do both read and write on the socket. And it also needs a input stream object for the standard input device, and again all of this is going to be read and written as a string at a time. So therefore we need a data input stream and output stream objects as well, and the print writer object. So those objects are getting created as follows. We're calling sockets get input stream, so we get the input stream of the socket, pass that to data input stream, creating another data input stream object for system.in, creating a print writer object for socket output stream. In a while true loop till we receive EOT from the client, we read from, as this is a server, first thing that we do in a server is we are reading from the socket input stream. This is again a block level call till the client sends a message. The readline method will be waiting to receive a message. Once the message is received, then that content is displayed and it checks whether EOT has been sent. If so, it breaks out of the loop. Otherwise, we reply to the client. So we are entering the content from the keyboard here using rdis.readline, and that is written to a socket output stream. So once you write to the client, again you come back and read from the socket input stream, check whether if it's EOT. If so, come out of the loop and then close the server socket first and then the socket object. So this is the client program. Now in this this is a server program. In this particular server that we have written, how many clients can connect at a time? In this case, it's only a single client which can connect at a time. So now let's run and see how this works. And then later, I would like you to convert this particular program to a multiple client server. So which means to say that you need to convert this program such that this server should be able to access multiple client requests and then reply back to these multiple clients. So many clients should be able to connect to the server. So let's run this program. Again, run the server first and then the client. So Java server to run the server program. As you notice, it is about to create socket and accept, that is, it is called the accept method. It is waiting now for the client to connect. Now let's run the client. So Java client. Notice as soon as the client connects, it comes out of the accept call. Now it's waiting for the client to write to the server. So let's say you enter a message. Now here, click at the server to reply back to the client. Come back to the client. Client has received the message which the server has sent. So now you need to write from the client to the server again. Right? Once this is done and you want to end the execution, type in EOT. The program comes out of its execution. So this is your TCP/IP programming using socket and server socket. So this is about few of the examples in socket programming or in networking. As we mentioned, we also have other contents that you could go through in networking concepts, like you can have a multicasting, that is, you can have group of people or group of client put together which can receive a message that is sent to that particular group. So you can group together clients and place a message. That message would get sent to all the clients like a broadcast. Then we do have protocol handling, that is, you can define your own protocols and execute them. Those are all called as protocol handlers. You can define your own MIME types, and that's nothing but content handlers. So this ends with networking.